Hi, Mike.
Hi, Anand.
How are you today?
Oh, very fine. Thank you. It's a nice day, nice sunny day in Montreal, so everything's hunky-dory.
That's great. I have a sore throat, but nothing really serious. So I hope you don't mind.
No, no, I hope you recover soon.
Yeah. So today my guest is Mike Florian. He's Professor Emeritus of Computer Science and OR at University of Montreal. He has more than 60 years of practical and academic experience working with OR problems related to the transportation of people and goods. Mike has published over 150 articles in scientific journals and conference proceedings on transportation research and OR. He was an associate editor of several journals, including Operations Research, Transportation Science, INFOR, Transportation Research Part B, to name a few. He was the founder of a company called INRO, whose transportation planning software packages are used in many countries worldwide. In 1990, he was elected a Fellow of the Royal Society of Canada, and in 2006, he was named a Fellow of INFORMS. Mike is a recipient of numerous awards, such as the Merit Award of the Canadian Art Society and the Robert Herman Lifetime Achievement Award. Mike was also recognized as a pioneer of computing in Canada by the IBM Centers of Advanced Studies, and he was named Honorary Professor by Shanghai University of Science and Technology. Mike, such an honor to have you here today. Thank you very much for accepting the invitation.
It's a pleasure.
So let's start, Mike. You actually prefer Mike instead of Michael, right?
I think so. Everybody calls me Mike.
Okay.
Everybody calls me Mike. My students, um, anybody that I meet, I prefer Mike. No Professor Florian, no Dr. Florian. I find that a little too pretentious.
Okay. So, Mike, you were born in 1939 in
Yeah,
Romania.
a
Uh,
long time ago. Yeah.
from which part exactly of the country?
Yeah, I was born in Bucharest, and I lived the first few years of my life through the Second World War. Uh, as it turned out, um, there were some memories. I have some memories from that time. I remember going to our balcony and seeing American bombers bombing the oil refineries north of Bucharest, but in general, I don't have very negative memories because of its location far east. You know, the war got to Romania late in 1944, and by that time, the Allies and were pretty close to Bucharest, and the Prime Minister made sure that nobody was touched in Bucharest. So we were relatively safe.
Right. So you have some recollections, but nothing really traumatic.
Nothing dramatic, no.
Okay, that's good.
Uh, what was a bit more traumatic is in 1948 when the Iron Curtain came down. That had a big impact on my family. My father's family owned a department store in Bucharest, which was a branch of Galeries Lafayette of Paris. And it didn't take long for the new government to nationalize the business, put the old management out. I mean, they sort of lost their positions. And if you like, in general, harass the old ruling class, of which my father was a member of. My father was executive vice president of the company. So this led us eventually to leave Romania. My father wanted to um, have another future, to have, he didn't think that under the communist regime there was much of a future for all of us. So we immigrated in 1950 to Israel.
I see, Mike. Are you an only child?
Yes, I am an only child, and
Mm-hmm.
um, yes, that I don't think my parents planned on having an only child, but this is how it happened.
Mm-hmm.
And of course, um, you know, during the war, when the war broke out, not many families were increasing the number of children that they had to take care of. It was a high period of insecurity, and if you look at birth rates, They were born before 1939 and after 1945, but in between, not much.
Yes, yes. Did you have good education in elementary school in Romania?
Yes. Well, my mother was a linguist, and she insisted that I go to. I went for the first 3 years of my life to a Catholic French school that was run by nuns, where half the education was in French. So I learned French at a very young age. So I did that for 3 years, from 45 to 48. And in 48, when the Iron Curtain went down, that school was closed, and I continued my education in regular elementary school, which came with all the bells and whistles of the new regime. It actually it was a good time. I was always a good student, so school never posed a problem for me. But uh, the regime change did affect my family quite a bit.
Right, yes. Were you forced to learn Russian in school?
Yes, yes, I learned 2 years of Russian, and actually I forgot most of it, but I had to go to Russia much later, like 10, 15 years ago for work, and I could actually read with Cyrillic characters. Couldn't talk much, but at least I could tell which was a restaurant and which was a hotel.
Wow, that's very impressive. How did you use to spend time other than going to school back in Romania?
Oh, um, I had this dream at that time of becoming an aeronautical engineer, and I started building model airplanes, planers, and then little model airplanes with propellers. And I actually found it very interesting. I got books about aerodynamics and about the wing profiles, and so it was a nice hobby. And I continued that hobby throughout high school later on. And now I didn't turn out to be an aeronautical engineer, but it was a great hobby to do.
Right. Your family had to move to Israel in 1950, as you explained, due to, political issues and so
Political
on.
reasons, yes.
Right, yeah. And how was your education in Israel?
Well, the level of high school in Israel was well. I was 11 when I got to Israel, so the first 2 years were finishing elementary school, and then I went to a high school which was very strong in science and math. I can tell you that I received a very, very good education. When I later on, when I got to Canada, the first year engineering at McGill University, there wasn't very much that I knew that I learned in the first year. So it was really a very good school, and it gave me a very good preparation uh, for later on.
Hmm. It seems that many of your fellow colleagues got a PhD degree later.
Yes, out of 63 graduation, uh, 37 got PhD degrees in various science areas, and it was a very, very competitive class. So it was good. It was great.
Yeah, I mean, 37 out of 63.
Yes.
This is
Yes.
incredible. And what type of activities did you take part in as a teenager in Israel?
The teenager, I joined the Boy Scouts, and I, um, I was very active in the Boy Scouts, both in terms of the regular activity that people do, like hiking and learning about living out without support, like living on the edge of the desert and doing tents and putting away tents and doing walking at night, orientation, all the things that scouts do. And I played organized basketball. Even though I'm not very tall, I played organized basketball for 4 years. So it was full, plenty of
Wow.
things to do.
Yeah, you were really busy. And you played
Yeah.
as guard because you mentioned you're not very tall.
Guard, guard. I played guard. Yes.
Okay.
Yeah,
Uh,
but
mhm.
I weighed a lot less than what I weigh now, and I was much faster than I am now.
Wow. And your family moved to Tel Aviv or other city?
No, no. We moved to a town near Tel Aviv called Ramat Gan. At that time, it was a separate town. Later on, when I went to Israel for work, it's hard to distinguish the two because there was a lot of urban development. But when I lived there, it was about a 10-minute bus ride from Ramat Gan to Tel Aviv. It's like a almost like a suburb of
Right.
yeah.
What type
Yeah.
of books did you like to read in those days?
Well, adventure and spy books. I was always fascinated by spy stories, trying to figure out, and detective stories, trying to figure out from the beginning who was the bad guy. So, yes, um, I was an avid reader and continue to be an avid reader right now.
That's very good, right? Not only to pass time, but it also keeps the brain active and is a very good distraction.
Oh, absolutely,
Yeah.
absolutely.
Any musical preferences?
Musical preferences. I mean, I do love classical music. Again, because of my background in Bucharest, I played the violin for, I believe, 3 years. I hated every minute of it, but I did get a taste for classical music, and both my wife and I are classical music lovers, and we go to as many concerts as we can.
I see. And what about other genres like jazz?
Yeah, we like the quiet jazz, not the noisy jazz. David Brubeck, jazz that old people like. Um,
Okay.
it's not the well, New Orleans jazz, quiet jazz, but there are forms of jazz that are a little bit more intense and with higher decibels, and we don't like those.
I understand. Yeah. Are you into like Coltrane and artists like that?
Yes, 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 definitely.
Mike, what made you leave Israel and move to Canada in 1957?
Well, I cannot go into all the details. There were circumstances. I was supposed to go to the Technion, become an engineer, but there were complications, which I don't think is any point getting into in great detail. It turned out that I had to lose a year. I had to, instead of going to the Technion, I had to stay home and wait for a year. It had to do with fitness, because one went to the army at the same time that one went to the Technion. And this idea at 18 to stay home for a year and do nothing was really very troubling. Fortunately, I had family both in New York and Montreal and on the West Coast, and I did get permission to go to university in North America, and I chose to go to McGill. And I was put up by family. My grandmother was one of 15, so the number of cousins that I had is exponential, an exponential number. But uh, yes, so that helped a lot. So this is how I ended up at McGill.
Yeah, you went to study mechanical engineering there, right?
Mechanical engineering, yes. As I said, I wanted to be an aeronautical engineer. Now, as I came to Canada, Canada at the time was producing a most advanced fighter, the Avro. I don't know if you heard about it. And our prime minister at the time decided to stop the program because he thought that that would bring too many interested parties to try to steal the design. So I realized the minute I got to Canada that mechanical engineering wasn't, I had to finish it, but perhaps that wouldn't be a lifetime occupation. But so to continue, is what happened is it's personal. A short time after I was in Canada, my father passed away in Israel. And then there was a question whether I should go back or remain in Canada. So I stayed. And um, I'm not sorry I did. I adapted to life in Montreal and at McGill. Within 3 years, I was a campus politician. I represented engineering on the Students' Executive Council, and uh, and I just loved every minute of it. And fortunately, my mother eventually joined me, and so there I
Wow.
was.
Yeah. I mean, you really got adapted to the environment pretty fast to the point of being politically involved in the university, right? So that
Well,
shows that.
I was always active, and it took a while, until my English got smoothed out. Um, but what I did do is I joined the McGill Debating Club, and that helped polish the language quite a bit.
Yeah, excellent. You said that your mother
Is
joined you in Canada 3 years after your arrival, and it
Yes,
seems that she became a quite successful fashion buyer, didn't she?
yes, she was a very able lady, and she started out modestly as a fashion sales lady. Within 3 years, she was a fashion buyer, and she had a career as a fashion buyer for a large department store until she retired, until retirement age.
So she had a very good life in Canada despite all the challenges she had to overcome back in Romania and Israel.
I think that she dedicated herself to the job. She knew fashions from before, and so she was very clever. She had very good mathematical ability, and so she did very well as a fashion buyer.
That's great. So no R experience during your undergrad years at McGill, correct?
No, I had absolutely no art experience. I took the standard mechanical engineering courses, and how I got into war was by chance. I had a very good friend who graduated a year before me, also from mechanical engineering, and he went to work in the OR group of the Canadian National Railways. And I used to talk to him, and he said, this is very interesting work that you have to do. It's much more interesting than going to work in a refinery or for a car assembly plant. So I went to the interview, and I told the manager that I knew nothing about OR, but I heard it was very interesting, and I'm willing to try it. I had a very good academic record. So I guess he gave me a chance, and that was my start in OR.
Wow.
And I learned quite a bit while I was there. At that time, PERT, doing project planning using PERT diagrams was new. So I did quite a lot of that. And then I worked on the beginning of massive information systems about the location of cars, of any car. Don't forget, that was a long time ago. I mean, we're talking in 1962. So that's a long time ago, and computers were nowhere where they are today. So essentially, there were cards. Each boxcar had a card, and each track had a drawer of cards. And the beginning of this information system was people taking cards by hand from one drawer to the other to keep track where the cards are located. And I mean, now everything is automated, but that was the beginning of an information system or what is called in the railways as a car control system. So I worked on that for, I'd say, about a year and learned a lot about the railways. So it was good. I wasn't very diplomatic. I had to work a couple of night shifts, and I found out that some of the railway workers who were doing shunting of cars tried and did everything quickly until 3 o'clock, 3 a.m., and then they went to sleep. and there were trains passing by and they missed them. So cars were being shuffled and they were sleeping. So I went back to head office. I busted into the office of the vice president and I tell them, you guys are sleeping on the job. Well, I got a few lectures about how to deliver this kind of news after that. But again, it was very good. It was
Yeah,
I learned a lot about everything that had to do with transportation, which served me very well later on.
incredible. So you learn about the war, transportation, railway systems, system development, managing people, like human resources, if you will.
Yeah, yeah, yeah.
So a lot of things.
Well, but I did realize that my background in OR was lacking. So I decided to go back to university. So I went again, applied to many universities. At that time, one is had to do aptitude tests, and I ended up at Columbia University, Industrial Engineering and OR program. OR programs in 1964 were not that many, so that was one of the few OR programs available. I mean, the choices were Berkeley, MIT, Northwestern, Princeton, pretty well. Yale didn't have anything, and many of the secondary universities didn't have anything. So I went to Columbia, where fortunately I had some relatives in New York as well, which made it easier. And I put my nose to the grinder and I learned. I learned mathematical programming. I learned mathematical statistics. I was interested also in social psychology, the organizational behavior, and given my experience at CN, at the Canadian National Railways, I was interested what academicians have to say about it. So in 3 years, I think I took something like 20 courses to
Wow.
try to sort of improve my background. And I was very fortunate. The idea for the thesis came after a lecture of one of my professors, and essentially it took about 2 weeks to work out, and then another 6 months to write up.
Wow.
Yeah.
You got some master's degree in the process, but not officially. How did that
Yes.
happen?
Well, I took so many courses. At that time at Columbia, if one had so many courses in a discipline, one can get a master's degree without writing a thesis, particularly if one went on to a doctorate. So I have a master's degree in OR, which I paid for. I have a doctorate in OR, which I paid for. I could have had a doctorate, I mean, a master in mathematical statistics and in psychology, but I simply didn't have the money to pay for the degrees. And in the end, I mean, now looking back, it doesn't make any difference.
I see. And what did you study during your PhD?
Oh, I studied production planning problems, which at the time were sort of topic of the day. And there were some students at Stanford who were working on the same topic. And essentially, it was a question of how does one handle capacity constraints on inventory and production capacity. And since production costs are usually concave, it turned out to be the trying to solve minimization problems, concave cost network flow minimization problems. The constraints, if you like, the conservation constraints for production and inventory turn out to be network constraints. So it was interesting. A concave function gets minimized at its extreme points. So all my thesis is characterizing the structure of these extreme points and doing dynamic programming algorithm to solve for the optimal production schedule.
Right. So you had theoretical and practical contributions in your PhD.
Yeah, yeah, and the computational. Yeah, yeah, I implemented all these algorithms on a IBM 1790. Yeah. Actually, when I came back to Montreal with my thesis written, I had a drawer of cards. I mean, it was still the punch card era.
Yeah, you had to keep them in a certain order.
Yeah,
Otherwise, it,
yeah. God forbid you drop them.
yeah.
Yeah.
Were you able to publish the results of your research in a journal?
Yes, yes. I finished in 1969, and together with my thesis advisor, Morton Klein, published a paper on one of the chapters of my thesis in 1971 in management science.
Mm-hmm.
And well, I must tell you that between finishing Columbia and going to work at University of Montreal, I did have a stint in industry. So I didn't go directly to university. Uh, I thought that my future was really to do scientific work in industry. So I worked for a paper company, and I continued in the area of transportation. I did logistics studies, optimizing the transportation of newsprint from Canada to the UK. I built a model, simulation model, from the factory to the end client, and we tried to find what is the optimal ship size for and what are its characteristics. There were new material handling for newsprint, and I came up with a specification for a ship, and the company hired a naval architect, and I worked with him for a week. And he said, yes, I can build those ships. Those ships were built, except by the time they went into operation, I was no longer working for the company. I had gone to the university, but I was invited to see the ships.
Uh, that's very
Yeah,
nice. Mike,
yeah.
you mentioned that you got a degree in 1969 in New York. That was the same year of Woodstock, which took place in a location relatively close to Columbia University. Did you attend the festival by any chance?
No, I did not. I did not. I was too serious and too square.
Yeah, you know that I have interviewed Bob Fuhrer from one of the co-founders of Ample, and he attended
Yes.
the festival, and he was there, among the chaos and sleeping near the stage. So
Well, actually, I think what we all saw was the effects of Vietnam War. 1968 is the time of the Students for Democratic Society. You see and they had demonstrations on the campus, and again, I didn't participate. I was Canadian. I couldn't really identify, but I understood why people were demonstrating against the Vietnam War. So yes, there were some exciting times in Colombia, but no, I did not attend Woodstock.
Mike, you were recruited by the University of Montreal in 1969. How did you get the job?
Uh, the University of Montreal was developing computer science and operations research, and there was a registry of students that had gone and got degrees elsewhere. So the then director of the department, who was trying to build up his department, just actually invited me to visit the university, and he made me an offer I couldn't refuse. He said, "Come for 3 years, and if you don't like it, it cannot hurt you." He was an outstanding person. I had very good communications with him. So turned out to be the fourth professor hired in the department of, in French, it's informatique et recherche opérationnelle, computer science and operations research. And the rest is history. The department grew. It had some outstanding individuals. Actually, one of the current members of this department is one of the big thinkers in AI. Joshua Bengio is a colleague. So the department grew, and my colleagues were very, very able. We were fortunate that it was a time when this discipline was developing. So young graduates, there were plenty of excellent young graduates to to look at.
Did you start working on traffic and network design problems as soon as you joined the university?
No, I did not. Um, the I worked on for a couple of years. I worked on combinatorial problems, scheduling problems. I involved some of my colleagues, and we did theoretical work, various scheduling problems, job shop scheduling problems, um, and we did very well. We published a lot of papers. You know how it is when you're a young professor: publish or perish. But what was most interesting, it was the time before the internet, and I heard about an Australian researcher, Graham McMahon was his name, was working in the same field. I saw a paper of his. I saw the mistake he made in his paper. I wrote to him, and we ended up co-authoring a paper together without meeting him face to face, without having no telephone, no nothing, just letters, and it worked. So, international collaboration worked before the internet and before Zoom and the means that we have right now to talk as if one is next door.
Wow, so an international collaboration between Canada and Australia in the early 70s, without the technology that we have available today, it's really remarkable.
Well, let's put it this way: we were young, and we were keen, and we wanted to do a lot of things. So, yes, that was like that.
You found a way to make it happen. That's
Yes, we found a
brilliant.
way.
Yeah. And what is the story behind the Center for Research on Transportation, better known as CRT?
Yeah. Well, what happened was that in 1973, the Ministry of Transportation of Canada judged that there were insufficient number of university graduates that had a good background for working in transportation. So they could not affect the academic program, but they initiated a system of grants where one would found a university transportation research center, and they would provide funds for research projects that were relevant in the area of transportation. And the rector of the time, so the university founded the center because they wanted the money. So the rector at the time scratched his head and said, "Who do we make director of? Is there anybody who knows anything about transportation?" And they found me. So I got invited to the rector's office, and they said, "You're the director of the center now. Go ahead and do it." So it was it was a new experience. The funds were there. One needed ideas, so we had good students. We had very capable colleagues, and university professors always look to finance their research. And we started looking around, and we identified areas where we could we had our background in mathematical programming, and we had a background in statistics, data analysis, and we realized that what the engineers were doing in terms of simulating transportation networks was not very good, was heuristic. There was an established practice. So we realized that the proper models could be solved by mathematical programming methods and very efficiently, not by heuristics like it was done before. And so, in order to find what else somebody else is doing, in 1974, I organized a symposium on network equilibrium methods, which again, people started seeing that that was something new and interesting, the same way as production planning was 10 years prior. And we managed to, because of interest of the funding, we got funding from the American Ministry of Transportation, it's called DOT, Department of Transport. So there were a lot of Americans, and so this is a possibility both to meet people. And so we had people from Europe, from Sweden, we had people from the UK, we had people from the United States, and we had some of the big stars in the field. If you do mathematical programming, you know about the Kuhn-Tucker condition,
Of
right?
course. Uh-huh.
Well, Harold Kuhn attended this conference and became a friend, actually. And the person who first formulated the model properly, Martin Beckmann, he was a German econometrist who worked at Brown University. And so I went to meet him, invited him to come to Montreal. And it was a great meeting. We had something like 75 people, and people spent until midnight arguing, discussing. I should also mention a lady who passed away relatively early, Stella de Fermos. She did some of the pioneering work in this area. And of course, there was both friendship and academic competition. So you know how it is in academia. But it worked very well, and we managed to really leave our mark. I mean, the center, if I look at what the center did, we made a lot of fundamental contributions to the algorithms to solve these methods. And then came the practical side. People started saying, yeah, you guys know all theory, but does it work in practice? Because our stuff works in practice. So we were fortunate to get a grant from the Ministry of Transportation to do a big study in a Canadian city to actually show that it is valid in terms of um, being able to be calibrated and reproduce existing flow, and then look at scenarios and make reasonable predictions if the network changes, what would be the and that was the city of Winnipeg where we did that. We did some academic codes that we used to solve it. They were not very professional. And then, of course, we wrote papers. So we published papers to say that this is valid, and it
I
was
see.
appreciated by our colleagues. But then we realized that our ideas were being taken by people in the US from the Department of Transportation and being given as contracts to American companies to implement what we were doing without involving us. Well, we decided then that we have to do our own. And by that time, I had an incredibly talented cohort of graduate students. That included a Swiss student, had several Swiss students, Heinz Spies, who had done work on similar models in practice for a consulting firm in Switzerland. So we got more funding and we developed the first version of what would be the commercial program that does all these analyses. There was something different about what we did, is that it's a question of vision, how one looks at a city. Everybody that worked before us were looking at transit, were looking at cars, were looking at pedestrians, and they had similar models for each. And my idea from the very beginning was that one had to do one model that contained all the means of transportation, because there is interaction between means of transportation. There is one mode influences the other. There are transfers. So M was the name of the program, and the last ME is EMME. ME stands for multimodal equilibrium. So that was and EM is in French, equilibrium multimodal. So the idea was to try to get a model that can simulate everything in a city. And I must say, we had very good initial success. It took us from 1980 till 1983 to have the first outside installation. But after that, people were asking how much does it cost, and when can we have it? So then we got organized with the university, and the university gave the rights to market the software, and we paid royalties to the university. And of course, Heinz and I, being still at the university, Heinz had become professor at the university. We could not benefit personally from any of these, if you like, royalties that we paid to the university. But the arrangement worked well. Heinz returned to Switzerland, and I continued until the age of 65 to work at the university, doing both jobs. And I must say that that was one of the most productive part of my career because I had constant new ideas coming from the practice of situations that we had not considered as academicians, but which had academic solutions. So, yes, so there were lots of doctoral theses, lots of master's theses, and it was just a very, very exciting time. Now, if we go back a little bit, I was director of the center from 1973 to 79. So all this activity with the software and the application came after my sabbatical. And of course, you know that I spent part of my sabbatical in your beautiful country. I spent 6 months at PUC in Rio de Janeiro, where I made many, many friends, and to where I returned many, many times after that.
Yeah, I mean, you have done a lot as a director of CRT. You have demonstrated the practical use of all your theoretical and algorithmic contributions. So, I mean, the impact and relevance of your work is just astonishing. And it's great to hear from you, right, from your own experience and how everything was accomplished back then. So that's
Yes.
wonderful. Before we talk about your period in Brazil, I just want to ask you a
Yeah,
couple of questions.
sure.
Somewhere during the mid to late 70s, you visited George Dantzig in Stanford. How was it?
Yes. Okay, this is the beginning when we did a theoretical work on the network equilibrium methods. These turn out to be network flow problems, multi-commodity network flow problems with minimizing convex costs. And one of the methods that we tried is the convex simplex method. There is a variant of the simplex method to solve convex optimization problems. And the reason it is called simplex is because it has one thing in common. One changes one path for another, and each path is an extreme point. But the mechanism is entirely different than the simplex method for linear costs. Now, George Dantzig was interested, and professors go for giving seminars here and there. So we received an invitation to give a seminar conference at Stanford University. So my student Sang Nguyen, who then became assistant dean, had a career of his own, professor and assistant dean. We went to Stanford, met with good old George, and make the seminar. And he was really such a nice man that it was just a pleasure to meet with him. So unpretentious. And we were, by that time, we had already seen quite a few stars in the field. And some others are a little more pretentious, are a little more sort of I'm important kind of thing. But George Dantzig was just a regular run-of-the-mill guy who was just brilliant and just very nice.
Very
And
interesting.
and I can only say that the field is lucky to have had someone like
Uh,
George Dantzig.
so he
Yes.
was not only a brilliant scholar, academic, but he was very down to earth, according to your
Yeah,
recollections.
yeah.
And
And I remember what he said when he really saw what the convex simplex is all about. He said, "Well, it's just too simple."
wow, you also met Egon Balas in the early '80s, right?
Yeah, I've done this work on scheduling problem, this combinatorial optimization. And when I was a student, I had to present a paper that Egon has just written about zero one programming. There's the additive method for um, zero one program, and there was things I didn't understand. So I actually wrote to him. He was professor at Carnegie Mellon, and then I didn't know that he had come from Romania as well. And then we met at a conference, and we became friends and met his wife. My wife met his wife, and unbelievable man. He was productive until, I don't know, until nearly 90 years old. He was still doing new math and new things. Truly outstanding man. But you know what he was before he became a mathematician?
Yeah, I know
He
I
was
know
a
he had,
diplomat.
yes.
He was a diplomat. He was a politician.
Mm-hmm.
And then, when again, because of changes in government and so on, he decided to have a career in academia, and he did very well.
Yeah. At some point he was even arrested. So he
Oh, you
had
know
a,
the story.
yeah.
Yeah, yeah.
Yeah. Uh, Mike, in his subject to episode, young Karel Lenstra spoke about he and Alexander Rinnooy meeting you a couple of times during that period. What do you remember from these encounters?
Okay. Other than the fact that they're great guys, they were students, and I was a young professor. I'm a little bit older than them, and um, the the common thing was combinatorial problems, because we'd work on these job shop scheduling problems, which are combinatorial problems. There were various algorithms, and most of them were branch and bound, branch and cut. This, and they were working on similar fields. And I think it was a conference in Amsterdam, and we met. And then I said, if you would like, by all means, you can come visit Montreal. So they did come and visit Montreal, and we worked together. But then they saw the subject of my thesis. This problem, this model that I did for my thesis, and that was a time when people were going into computational complexity. It was a time where people were saying, "Come, problem is NP hard, so you'll never be able to solve it properly." When there was this fashion of, "Man, we can solve NP hard problems, no problem, but just you cannot solve it with a polynomial algorithm." So Jan Karl saw, he picked up my reprint. He looked at it. He says, "That's an interesting problem. Why don't we look at its complexity?" I had done a dynamic programming algorithm that worked well on small problems. And of course, they proved that the problem was NP hard. And so altogether, we had a lot of very good academic exchanges. And then we published this paper uh, on, which was in 1976, I believe, on computational complexity of the, and the people quote the 76 paper, forget about the 71 paper, because it's more interesting and more complete.
Uh-huh.
And of course, we kept friendship. Alexander became a politician, as you well know.
Mm-hmm.
He was elected to parliament, and he was a minister for a while. And we kept meeting at conferences here and there. And whenever we were in Amsterdam, we always got together and chatted. Yeah.
That's great. I was excited to learn that you spent a sabbatical period in Brazil, as you said earlier. When that happened exactly, and could you share some details about it?
Yes. So in 1979, my term as director of the center ended, and my son was before school age. So that was the only opportunity to take a sabbatical and go somewhere else, because later on, once he would be in school, it would be very, very difficult to move him. So I had met some professors from PUC at conferences, and I had met Makulan. You know Makulan, don't you?
Absolutely. I have
Yeah,
interviewed
yeah.
him, and he was a supervisor of my master's supervisor and my PhD supervisor, so I know him really
Right,
well.
right. So I got this offer to go and work at PUC, and the reason I went to PUC had to do with transportation. I didn't feel like driving in Brazil, and um, the federal universities is out of the center of the city,
Yeah.
and Well, it was a bit of a culture shock to go from Canada to Brazil, but we took it took a good month, but we adapted to it, and we lived very close to the university. I could take a bus to the university, and there were plenty of students that were waiting for somebody to look at what they were doing. So I had good interaction with the students, very good interaction with the colleagues, and there were four professors that I interacted with, and the chairman of the department, Nelio Pisolato. That's the name I was looking
I
for.
know him.
Uh, You know Nelio?
Yeah,
Yeah,
tall
yeah,
guy.
yeah. So, and actually, one of the students that I had there, he continued, and I helped him with the doctorate, and I went back to Rio for his defense. So, and I had another project too that gave me a chance to go back to Brazil. So this is another thing that I did during those busy years. Uh, Brazil had, at the time, which is probably puny compared to today, a rather significant negative trade. It had a trade deficit, and there was an interest to export as much as possible. And the freight network of Brazil was somewhat underdeveloped. At the same time, we had our prime minister, um, who's the father of the current prime minister, Pierre Trudeau, who wanted to establish links between North and South. So again, how do you establish links? You provide money. So we got a grant to work with PUC and with JPOT, that's part of the Brazilian Ministry of Transportation, was their transportation planning arm, to build a freight model for Brazil, which would identify potential areas for investments to increase the output, harbors, railways, and so on. So that project lasted 6 years, from 1983 to 1989. The colleagues from PUC participated, people from JPOT and us, and we we involved about 6 students in the project. So there was lots of, if you like, applied research to do with freight modeling, and how is freight modeling different than modeling individual travel, and how does one model railways. And again, we published several papers that are quite well received about how to model at at a certain level transport by rail, how to take into account single track, double track railways, how to estimate the demand for freight. And one of the biggest difficulties in trying to do a model of freight is to estimate the demand and the timing of the demand. Actually, to tell you the truth, there was a big problem with rail capacity in Brazil at the time. I will not mention the place because it's irrelevant, but at some point there was so much demand that the railways couldn't accommodate it on trains. So the railways were hiring trucks in order to complement the capacity of the rail in order to transport the goods. Now, so there was a big capacity problem. And so we spent 6 years building this model. And during the 6 years, when one builds a model, one looks at data. We got data from companies, we got data from operators. We talk to people who run trains. We There's a big company, um, Vale de Rio Doce, the
Yeah.
iron ore company, very competent, extremely competent. So we put all this knowledge together, and we built this model, and then at some point, the model, I don't even know if the model exists anymore, but there were things in Brazil that were really stunning in their size. There was a Ferrovia de Aço, Ferrovia de Aço, that
Hmm.
was built but never used.
Yeah.
It was in the 80s. It was 1 point something billion, but they found iron ore on the surface. So instead of running trains with iron ore from Belo Horizonte to Rio, they as this company Vale de Rio Doce was just running them to the port of Vitoria. So it was very instructive, and I hope that we did contribute something to the people who were making policy, who were doing policy. Um, um, Brazilian bureaucracy has many levels, and
Yes,
we did
it hasn't
get,
changed much.
we did get to sort of one level below the top. Whether we had an impact or not, I will never know. But I know that the colleagues at PUC, with whom we lost contact eventually, continued to do work in this area.
Mhm.
So yes, I visited Florianopolis. I had to visit Florianopolis. The south of Brazil is really very different than Bahia and the north. But I had to see the city. Absolutely.
Yeah.
I couldn't go to Brazil and with the name is Florian and not go to Florianopolis.
Exactly. That
Yeah,
was exactly what I was going to say.
yeah.
So you had a chance to visit multiple cities in Brazil. Brazil is a huge country.
Yes,
So
I visited Recife, Bahia, São Paulo, Santos, the port of Santos, and then for simply tourist reason, we went to see the Falls de Iguaçu,
yeah, it's beautiful. Yeah,
which is beautiful. Yeah,
yeah,
which is really magnificent.
yeah. My city,
Yeah.
João Pessoa, is located about 120 kilometers from Recife. So we are
Oh,
relatively close to Recife. Yeah.
yeah.
And Mike, in 1984, you founded a company called INRO, which was
Yes.
sold in 2021. Can you briefly comment on the worldwide impact of the company?
Right. So we had this software that I had mentioned before, uh, that was already at a professional commercial level, and people started asking how much does it cost. And of course, any invention, anything that is developed in a university belongs to the authors and belongs to the university. So we negotiated, in other words, my student Heinz Spies and myself, we negotiated an agreement with the university to get the rights to market the software. The university put up some conditions, which I cannot mention, that in 3 years we should have done so much and so much. Anyways, we met the condition the first 6 months. So at the beginning, and people started using it, its use grew very fast. I think for the first 4 years we were doubling the number of organizations using it every year, and eventually we made friends all over the world. In the 90s, we decided in North America and Europe, well, that's okay, but there's a big world out there. There's South America, there's Asia. So we traveled the world. We went to Hong Kong, China, Malaysia, Singapore. By the way, Singapore and Hong Kong, my favorite places. Um, the Philippines, South Africa, North Africa, some of the countries in like Tunis, Morocco, and of course all the European countries. The UK. We have a lot of users in the UK, in Italy, and we made friends everywhere. And eventually we realized we can't do it all ourselves, so we got partners in different parts of the world who, if you like, did the marketing for us, and we kept INRO kept being sort of a place where new things were coming out every year in terms of modeling. And this is what I was mentioning. The interplay between the university and the practice during those years was incredible, because we were getting from the practice, we were getting ideas of what people needed and didn't have. And we would then take it back to university, study it. There were theses, there were papers, and then we would implement it as new features in the software. So when, make a long story short, you probably know that the company was sold in 2021, 3 years ago. By that time, we had users in something like 84 countries. One thing that goes with practice, every year we organize user group meetings where people using the software were presenting what they're doing and were complaining about the things that don't work or bugs or whatever. And those user meetings were just, talking to the user is really talking to the practice. So if I think that both the center and what I try to do is to bridge the gap between academic research and practice. You know the difference between pure math and applied math? Uh, Pure math, you do. Applied math, you do tomorrow. So that's a difference. So I think that actually all my colleagues at the University of Montreal at the center, they all in other fields had the same idea. Let's do good academic work, but let's put it into practice and see what doesn't work and fix it. So if you like, if I look back on my career, if I had a good time doing something, was doing this is listening to practitioners, going back and having the greater satisfaction of coming back with a solution.
Yeah, that's remarkable. Thinking about the idea of developing cutting edge technology motivated by practical problems and then providing a solution to those problems is just, the perfect synergy among the
Yeah,
parts and among
yeah,
university and the industry. So you really did
yeah.
great, for sure,
Yeah,
Mike.
yeah. Well, practitioners who use models don't know the math behind them, and we worry about uniqueness, existence, convergence, rate of convergence, all that sort of thing. The practitioner says, look, I need to model this and I don't know how to do it. Show me how. Then you go back and you see, can we do it? Can we not do it? And
Yeah.
sometimes practitioners request features which are simply not doable. And we had the courage to say sorry, but we cannot do that.
Yeah, which is probably the most smart thing to be done is sometimes you cannot do it and you just have to acknowledge that instead of coming up with something that would not fit or would not meet the expectations of the
Right,
practitioner, right?
right,
And
right.
so, Mike,
Uh,
you have supervised some important names from our community like Patrice Marcotte and subject to guest Michel Gendreau.
yes.
It should have been a privilege to participate in their academic training, right?
Oh, absolutely. I think that my good fortune is, and I'm saying it with all honesty, that I think most of my students, I really like them because I consider them to be better than me. I really, Patrice, brilliant. Michel, as you well know, he's very productive. Now, they are two of the best graduate students that I had. I never co-authored a paper with them based on their thesis because I felt that they were so good that they did it all on themselves and I didn't have a major contribution. Other students, we did a lot. Now, we did some papers together later on other issues, but not on the thesis. And that was my principle. If I help a student, I get my ideas, and if he gets his thesis and some of my ideas there, I'll co-author a paper. But if he did it all by himself, and all I did was just look and say, okay, then he does it on his own. And Patrice was one of those, and Michel was one of those. Later on, we did co-author papers as colleagues. And I must say that I was very fortunate. The other brilliant student that I had was Heinz Spies, this gentleman, the Swiss gentleman, who worked with me in INRO for a period of about um, 18 years uh, and really very, very brilliant. But again, I think I had something like 20
Yeah,
people who
yeah.
did doctors with me, so they were all very good. And but I must say that I learned a lot from my students. And the good thing is that we stayed friends.
Yes, I think I can share the similar experience. I had the chance to supervise many good students, and most of them are for sure more clever than I am. It just feels good to be surrounded by smart people, right? And
Absolutely.
uh, let's talk about your vast editorial activity. You have been editor and associate editor of INFOR, an associate editor of prestigious journals like Operations Research, Transportation Science, and Transportation Research Part B. What lessons could you share from this extensive experience?
Lessons to share. Most of the operations research, transportation science, and transportation research B were done when I was relatively young. I mean, between the ages of, I would say, 28 and 45. And I think this is a part in a professor's, a phase in a professor's career where he can contribute not only to what he does, but also to see what other people are doing and fix some of the things, some ideas. So I think it's hard work. It's unremunerated. It takes many hours. If one does it seriously, it takes many hours. I think that one benefits from it. Exactly how much one benefits if the paper is no good and you find errors in it right away was not much benefit. But occasionally you get an outstanding paper, and I would say if I look at all the papers I refereed, I would say if a third were very very good, it's a high number. Most of the papers that one gets a referee are not exciting, but some are, and those are worth the effort because one gets to know what other people are thinking, new ideas. I think in our field, particularly in operations research, there's a bit of multidisciplinarity. There's a bit of econometrics, there's a bit of optimization, a bit of statistics, and very often good ideas come from associating an idea from one field to the other. And I think that the great papers that I is learning from one field and saying, aha, I could do this with that idea. So it helps one, but it's a big price to pay. I was, I remember I would spend at least 15 hours a week at nights, refereeing papers, and it takes time. When one gets to the editorial level, and it's a bit easier because then you set policy, you look over what other people have done, you judge, if there's difference of opinion, you settle the differences, you adjudicate. But refereeing is hard work and it's worth it.
Right. And more on the editorial level, do you have any stories involving, let's say, unhappy authors or anyone who was not really satisfied with the outcome of the review reports?
That's a good question. Well, look, if you get your paper rejected, you're unhappy. Uh, but you think of someone coming and rebutting the referee reports and complaining about it.
Yeah.
No, I must say I've never had that happen to me, or if it did happen, it never got to me. Maybe it was settled by the editor of the journal, you know. But as associate editor, I didn't see that many, and as referee, of course, the chances of seeing that are even lower.
Hmm.
Um, no, I think the funny stories are of people who copy papers from others. I was several years. I was on the for many years actually. I was on the editorial advisory board of a couple of journals. One of them was Transportation Science, and there was a case that came that I had to look at where an author claims that another author just copied word from a paper that he did. This is while he is refereeing the guy's paper. So, of course, you have to handle it with kid gloves, and you have to inform the person who copied that, look, maybe you made a mistake with the award editor or with somehow or other this slipped through, but you should revise this. And so, the whole bit of refereeing, I mean, it's an honor system. And in an honor system, my opinion is you do not insult people. If they haven't done it properly, you show why. And if they do silly things like copying, you just confront them and say, perhaps you made a mistake, but that's not acceptable.
Right.
Yeah.
Mike, you were one of the early recipients of the Robert Herman Lifetime Achievement Award in 1998. Did that come too soon in your career?
Yeah, I did. I did feel it came too soon because by that time, I thought, a lifetime achievement award, you get, you get 5 years after you retire. People look at what you did and you get it. But I was still very active. And I felt that the Lifetime Achievement Award was, I mean, I was honored, but it was a little bit early. That could have waited a little bit. But I didn't refuse it. So, but I did feel that it was a bit early, and I did kept publishing way after that. I mean, I had this feeling, no, that's not the end of my career. I keep on going because a lifetime achievement award is I thought is given to someone after they finish their career and they're evaluated among against other people. But look, Robert Herdman got one, so I shouldn't complain because
Yes, yes.
Robert Herman was again one of these very, very outstanding people whom I had very interesting conversation with. Yeah, well, let me tell you about Robert Herdman. I spent a week at University of Texas in Austin on my one of my subsequent sabbaticals. Hani Mahmasani was a professor there, and I went to see what the students were doing. Robert Herman was an honorary professor there in Austin, and we had time to talk. Again, I was on sabbatical, and there was only so many meetings you go to a day. And Robert Herman thought that in order to understand how the transportation system works, we have to start from the individual, from the individual. For him, he was a physicist from the individual particle. He says, you guys do aggregate models, equilibrium models, where aggregate behavior seems to be more or less okay, but you don't really understand how things work. You have to go to the bottom level. And he did have a point because all the current demand modelers, who do activity-based demand modeling, they work trying to understand the behavior of the individual traveler and then aggregating to see what a forecast of travel would be. And the people who do micro simulation, they work with individual cars. So he was right. But of course, our models worked in practice, so it was fine.
Right. That's a very nice memory
Yeah.
that you had of him. That's so very nice of you to share. Over the years, you developed a strong connection with China, correct?
Yes, yes, that was started in the 90s when I went. I traveled to Hong Kong and to China, and I established first academic relations with the Hong Kong Poly University and William Lam in Shanghai, Tongji University, and East China University of Technology. And I gave seminars, and oh, I must tell you the story. So I'm in Beijing for the first time, and I go and give a seminar on transit assignment, on modeling transit to a local university, Beijing Zheitong University. It's one of the major university in Beijing. So that's fine. So we go to sleep. Somebody knocks on my door the next morning at 7:30 in the morning. I open the door. There are three Chinese students with a paper. He says, "We don't understand this theorem. Can you explain it to us?" That's 7:30 in the morning. So you can understand how eager those students were to learn and to get new things. So yeah, so between sort of trying to get some commercial agreements and let the commercial people do the selling. And between uh, university relations, I spent quite a bit of time in China. And I must say, it was the good days, when China was just opening, where the government organization were sort of being reformed, where universities were being open to the West. It was very, very good. And of course, the culture in China is so different than Western culture that it was fascinating to see. And again, I made a lot of very good friends. And but again, I haven't been to China for a while.
Hmm.
But for a period of about, I would say, 15 years, I was going to China every year. The
Wow.
other thing I should mention is that the University of Montreal, several departments, the geography department, our department, the transportation center, had a joint research project with several Chinese universities, and I benefited from that because they paid the travel to some
Hmm.
of these meetings. And yes, yes, I've seen a lot of places in China, I must say. But if somebody asked me where I wanted to return to, I would say Hong Kong and Rio.
Oh, that's very nice. I mean, you
What
left a mark in several
Ciudad
countries.
Maravillosa, no?
Yes, Cidade
Ciudad
Maravilhosa.
Maravillosa.
Yes, yes,
Yeah.
yes. It's known as Cidade Maravilhosa. I lived there myself. Actually, I lived across the bridge in Niterói. So I had this wonderful view of Rio de Janeiro for several years. And it doesn't take that long to understand why it's called Cidade Maravilhosa, which means wonderful city. So, yeah.
Right.
But come on, Mike, you left a mark in so many countries, so many places, such a long and wonderful career. I mean, it's incredible. And how is life after retirement?
Yeah, look, I retired from the university in 2004, once I completed 35 years. Now, they made me emeritus, so I kept for a period of at least 7, 8 years. I still had research grants. I kept working with students. After that, that work petered, and right now uh, I'm available whenever somebody wants to talk to me. They can talk to me from the university students. The company kept me busy after that full time until 2021. Then I stayed on as a senior advisor for the company that bought INRO. They asked me to audit some of the technical work that they have done. And in the end, I retired formally last November. So my full retirement is not that long. It's 6, 7 months. So, uh, but the fact that sort of the activities diminished after I I no longer ran the company gave me a chance to go back to some minor academic work, refereeing papers, evaluating research proposals, giving, judging promotions. So I still have 2 to 3 hours a day of work um, that I do every day that related to one or other technical matters. I try to keep up to date with what's going on. You being on ResearchGate and being on one or two other similar organizations, one gets new papers to read, to referee. So I'm trying to keep up to date. But my wife appreciates my presence because for many years I was traveling 2 weeks a month. So when we ran the company, I traveled while I was with the company 2.8 million miles.
Wow. It's
So,
astonishing.
well, it's not very difficult. Um, Montreal to Hong Kong is nearly 10,000 miles. So, Montreal to Rio is 8,000 miles. So, the fact that we have more time together, I think this is nice. And again, there's this standard thing that politicians say. They would like to resign and spend more time with the family. I do spend more time with my grandkids. I do spend some more time with my wife. So, but I still keep sort of try to keep at least try to keep active and current with what's going on.
Yeah, it's about finding ways to keep yourself busy, mentally active, and physically active. I know you like skiing and other
Yes,
types
yes,
of
yes.
sports.
Yeah, well, both my wife and I still do downhill skiing. We do here in north of Montreal some good ski hills, and we go every year with the family a 2-week ski holiday, and we do a lot of biking in the summer. So we try to cheat our age.
Yeah, I like that. How long have you been married?
Oh, I got married in 1972, so that will make it 52 years.
Wow, it's a long time. And Mike, do you have any regrets?
Regrets?
Yes.
That's another question. I'll answer it in a different way.
Okay.
When I went to Colombia, I took a course in managerial economics, and the professor was a very famous economist who was an advisor to the president of the time. And he gave us a quote by a fellow who developed the first chain department stores in New England. His name was Wanamaker. His name doesn't matter. And he said, half the decisions I make are wrong, but I never know which half. Okay? I'm sure I made wrong decisions, but I don't know which half.
Yeah. Good answer. Good answer. Mike, do you want to leave a final message to our young viewers and listeners?
Yes, well, this is what I used to tell all my students is that if you like something, go get it and spend as much energy and effort that you require to get what you want.
Yes, short and effective. I like that also.
Yeah.
So, Mike, thank you so much for your time. I had a blast talking to you, and I hope you have enjoyed the conversation as much as I did.
Yeah, it's been very pleasant. And thank you for inviting me.
Yeah, it was a pleasure, and I'm very happy that you have accepted the invitation. And I could stay hours, literally hours, listening to your stories, to your insights, and I'm sure the listeners and viewers will appreciate your body of work and your vast repertoire of experiences. So thanks a lot once again. And if you are interested in visiting Brazil again, you just have to drop me a line, and maybe you can meet one of these days.
Muito obrigado.
De
Thank
nada.
you so much.
Thank you so much, Mike. Stay healthy, active, and I wish you all the best. Ciao.
Ciao.
Bye.
Bye.